That is hail. Now around here, we don't get hailstones this big. This doesn't happen. So I've seen hailstones in the Northwest, and they get the size of, smaller than marbles. This would be like in Oklahoma or somewhere. They definitely can have some major hailstones. Uh, Here's a hailstorm, and here's like, oh, they're like bigger than golf balls here. And this can be really destructive for crops and things. You wouldn't want to be out in one of those hailstorms. Would be kind of a problem. They can break windshields. Uh, and so the hailstones, this is one of the world record hailstones here. Look at the size of this. This is inches, by the way, not centimeters. It's like 7.5. It says 7.5 there, but it's almost at 8. So I'd say, what's that? A little over 6 inches wide. Now this would be hailstones that are sort of frozen together. Let me show you how these things form. What's going on with the hailstones is the hail forms in cumulonimbus clouds. Again, thunderstorm kind of clouds, the same kind that make lightning and that kind of stuff, also will make hail. And so it's this rising air in a thunderstorm when they have the air masses meet and one gets pushed up really fast, either in an occluded or in a cold front, and that is what causes hail. And let me show you why. So everybody, on your piece of paper, here's a diagram you got to draw, okay? This will only take a second. Have your paper ready. Hail forms in cumulonimbus clouds. Write that down. Okay, so what we're going to do here is do a diagram about hail, okay? Hail. Now, remember, there's a couple of reasons why we're doing this, by the way, because I want to remind you what the deal is with the cumulonimbus cloud. So draw the ground here. I was thinking about having you draw a cumulonimbus in the earlier part, but let's just do it now. And so you got low altitude. There's the bottom of the cumulonimbus, and the cumulonimbus goes up and up and up. And as it's rising up, it's being, you got the two air masses clashing. One of them's getting driven up over the top. And so it's going up, and it hits the roof, basically, the top of the troposphere, and it starts spreading out. You get that anvil shape. So there's a cumulonimbus cloud for you. So you have massive, massive convection going on, where the air is being shoved upward, right? And then you get these, so you get snowflakes and stuff, raindrops and pieces of whatever start falling down as normal. But then they get caught in an updraft, they get taken back up, and they freeze again, okay? And then they drop, and then they get covered by, there's wet raindrops down here, so water gathers over that piece of ice, and then it gets caught in the updraft again, and it goes up again, and it freezes onto there. Now it's bigger, right? And then it gets so heavy, it starts falling down again, and then more gets down to the moisture where the raindrops are, more water collects on it, and then it gets carried back up again. And it's this up and down motion that makes every time it does that, the hailstone gets bigger and bigger. Now, or in the Pacific Northwest, we don't have giant thunderstorms very often. I mean, it's pretty rare. And so the big thunderstorms and stuff like you'll get in the Midwest, it'll cause tornadoes. That's coming up later. They'll also tend to generate large hailstones. Anyway, the hailstones, it's the updrafts that do it. By the way, here's an interesting kind of thing. If you want to invent some brand new kind of extreme sport, try cumulonimbus diving. Because if you had a parachute right there in a cumulonimbus, you'd be going up, right? You wouldn't be falling down. Anyway, that's another story. Don't try that, kids. That would be dangerous. Anyway, so this is a cumulonimbus cloud. Cumulonimbus. Okay, so anyway, they form an that's a L-O, cumulonimbus cloud. And then when they get big enough, then they fall down as hailstones, right? By the way, this up and down motion also is what separates the electrical charges to make the positive charges, the negative charges get stripped off, so you have negative charges gathering down here, and then you get lightning strikes. Okay, so anyway, that's why there are thunderstorms as well. The same process makes hail. Also, will tend to separate charges, like charge it up like a giant battery. Okay, hail. Yeah, so the cumulonimbus, it goes up and down, and that's what makes the hail form. And what's kind of interesting about it, again, you get that dynamics. It's all because of the uplift of the air, right? Now this is a pretty awesome hailstone. It's one of the world record holders, but you really big ones like this, you saw it in half and you can see the rings. This is like rings of a tree. You can tell how old it is. Well, here you can tell how many times it went up and down in the cloud, and that's how it got bigger and bigger each and every time. And then other things fall from the sky involving snow, but man, that's a brave skier. Okay, so anyway, there's precipitation.